Let's get started. So let me give a bit of background of why I put this talk together. I've come in some space, lots of space here. So, I wanted to sort of look at the question, how do we deal with security vulnerabilities in open source projects? And, and what's the best practice? Is there consistency and so on and so forth? In a sort of light that, software stacks are becoming more and more complex and, like in your traditional stack, you have lots of different layers. And so there's the idea that, if a particular project, a piece of your puzzle doesn't do security very well, then the whole stack's going to be vulnerable. And basically we saw a question up there, and we're going to have to wait until the end to get the answer. A little bit about me. I've been contributing. My name is Lars Kurth. I've been contributing to a number of different projects, GCC, Eclipse, Xen, a bit of Linux as well. I worked in a lot of different, technologies, and today I do the community stuff, for the Xen project. I happen to work for Citrix. I'm a member of the group which develops Xen Server, but I'm also the chairman, of the Xen Project Advisory Board, and the Xen Project is a Linux Foundation collaborative project. So, anybody disagrees with the fact that software bugs happen, and we can try to minimize that, but at the end of the day, there will be some vulnerabilities. And the picture or analogy, sort of see there is I'm kind of going to use this a little bit through the talk. Is this whole idea of vulnerabilities being like zombies, which can do a lot of bad things, and and then the way. But we'll get back to that at times to make it a little bit more fun. So let's start with. And by the way, just interrupt me with questions anytime. We have an hour, so we'll be. I can take one or two questions during the talk. That shouldn't be a big deal. So, I just wanted to sort of start with a little bit of terminology. So, at some point when you write code, bugs get introduced. The way how I look at bugs or vulnerabilities in this sense is, like it's like a broken window in your castle where somebody can get in, and coming back to this whole zombie analogy, at some point in time, somebody actually discovers, the bug. If it's undiscovered, or if the vulnerability is undiscovered, well, nobody cares, right? Nobody's going to do anything with it. Now, this could be, a bad guy who discovers it and does something, with it. Like sell it, exploit it, steal your data, game over. Not very much we can do at that point. But what we're going to look at is really that scenario where actually the discoverer, isn't as bad. They go and report the issue to your project. For example, via security@yourproject.whatever, email address, where you report vulnerabilities. And, that gets us to the point of actually how do you manage vulnerabilities? How do you do that well? How do different projects do that? What are the patterns, out there today, which are in common use? And then some of those have different trade-offs. So the way how I look at, at vulnerability management processes in open source project, it's really a little bit of a team effort. And so I wanted to draw back to that, zombie analogy. I don't know, who's seen The Living Dead or read, the comic? Okay. right? And then, like there's this scene where they, it's eventually, they found a prison, they managed to keep this quite secure. They deployed a lot of techniques to make sure that the zombies couldn't get in, checkpointing, made sure that everything is fine. And in many ways, what vulnerability management processes do, really, they're like a team effort, to make sure that, you find all the open doors and weaknesses. If you have them, you close them as quickly as possible. You make sure that all your doors are locked, that your windows are boarded up, and so on and so forth. That your fences have no weaknesses. And, that's kind of how I look at, vulnerability process. And then, it depends on how do different projects, live up to that. But before I go into this, let's just look at some of the common patterns which are around today in a very basic way. So the first pattern is full disclosure. So what does that mean? So, we have our bug being reported. Probably in this case, to a guy or a small team, a security team. They'll look at it, they put a description together, and then they announce it, possibly on a mailing list, and work on a fix. Eventually, the fix is available, and then probably make a little bit of a larger announcement and get everyone else, to deploy that fix. Now, the color scheme there is a little bit is important, because red means a large number of people know about that issue, and they could potentially exploit a vulnerability or bug during that red time period. And there is, and it traditionally has been, a little bit of a debate on responsible and full disclosure, but I'm not going to go into that. Just Google for it. There's been lots of controversy around it about what's better and what isn't. I kind of wanted to move on from that and push this a little bit further. So I was talking about responsible disclosure already. So that's the second pattern which is commonly used. And what does that really mean, and how does it compare to full disclosure? Well, basically, our bug that gets discovered, somebody looks at it. This is all happening in a very small team in private, behind that security ad list. The people who are on a security team will basically probably work together with the reporter and fix the issue. And then they will, will create a patch at the end of the day. That patch goes then to something which is typically called a pre-disclosure list. So that's a list, of people who have certain privileges, like it could be a number of key users, or it's not the entire world. It's a sort of select smaller group of people who get to know about that vulnerability and can do something with it. And I'll go into that, the kind of different models there in some more detail a little bit later, because what's really interesting is that there's large differences in how different projects deal with this. And then, of course, after the pre-disclosure period, you announce the list publicly, and then everybody else, deals with it and updates their systems. So that kind of gives us a little bit of the basic terminology. And, just to remind you, this whole process is really about keeping your users safe, and to some degree also minimizing risk, in the bigger picture. And coming back to that zombie analogy, right? Lots of zombies there on the right, and your little user there on the right, zombies on the left. Trying to fight them off. But I wanted to explore first, really, what does safety really mean? What do we mean by safety? What are the key elements, of it? Well, the first thing really to realize is for this whole process to work, actually, you need to encourage the people who find vulnerabilities in your software to actually report them to your project. And it's really, really interesting because actually they're totally in control. As an open source project, you can't force somebody to report the bug to you. You can't force them to not do something bad with it. And really, a robust process encourages people and companies, to report things to you. And we'll get to some of this a little bit later when I will talk about some of the, lessons I learned within, the project I'm responsible for, how we dealt with various crises, which then led to changes to how we manage vulnerabilities. Then, the second key part is really that once something is discovered, the issue has to be, fixed as quickly as possible. You just want to minimize, the time from when something is known to it actually being fixed. And, really, you don't want to have any unfixed vulnerabilities lying around. That can be quite challenging operationally also, depending on the size of the projects, how many people you have on your security team, and so on and so forth, but we're not going to address that in that much detail. And then, once a bug is fixed and you communicate it to the outside world, really you want to make sure that the exposure time is minimized and that your users apply patches quickly. Now there's actually not that much you can do as a project there. The only thing you can do is transparent about the issues you have, make them public, and maybe in some cases PR helps to get users to update their systems, but ultimately you don't really have any control over that side of the cycle. But we will actually cover and talk a little bit later about things like PR and some, and how the media sometimes covers vulnerabilities today, and what this may mean for your project, and what that also may mean for users. So I just kind of wanted to, with that bit of terminology we just introduced, I wanted to start looking at some of the of how different projects which are important in cloud computing handle these kind of things, just to sort of set the scene a little bit. So actually, there's a few examples who do of projects who do full disclosure, right? So so for example. And then there's a color scheme in there. Sort of yellow is there's a problem there, white is sort of usually okay, and then red, that's somewhere where there's a problem. So if you look at the first two lines, it's actually really interesting. So in Linux, if you discover an issue in the Linux kernel, it very much depends on how you report the issue. Depending on how you report it, that it gets handled differently. So there's different groups who handle security vulnerabilities, and they have different processes. So for example, if you report it via OSS security, which is a public list, it just gets published. It's full disclosure. If you report it via security at kernel org, they will look at it for 5 days. They will try and do a fix during that time and do a bit of triaging, but then it'll go out for full disclosure. Other projects, like OpenStack, QEMU, and a lot of them, they use full disclosure for low impact issues, but not necessarily, for important issues. Then, we have a whole list of projects which use responsible disclosure. Again, Linux kernel, if you report via OSS security distros, that's another, public mailing list. It goes through the responsible disclosure approach. Most Linux distros, QEMU, OpenStack, OpenNFV, OpenDaylight, XM Project, and so on, they all use that kind of pattern today. Then there's, I added Docker into that category as well. So Docker is kind of interesting because they say they use full disclosure, and I actually know that they do. But you go to their website and then you try to find a policy document and you can't find anything. You you have to ask, and if you're, if you're an important Docker user, then you might get access, to their policy document. And then we come to the area where we actually have problems, right? So there's a lot of newer projects or also other important projects where it's not clear at all, what they do. Cloud Foundry, for example, there's no clearly stated way of how they deal with, securities. There's no published CVEs. CoreOS, same thing. Kubernetes, same thing. And that's sort of true for a lot of the newer projects which have started more recently. I started giving this talk for the first time in August last year. And actually what's happened is, that the people of those communities, it was actually even worse then. At that time, there wasn't even a way to report a security issue to Kubernetes. And there was a Kubernetes guy in the audience, and I just added that, afterwards. But, coming back to the original question, that kind of already tells us that maybe there is something, wrong. There's a lot of inconsistency and different approaches going on today. And part of my talk is also about, if you work on these projects, go back to your communities and get them to think about that and how to address this, because ultimately, in the long run, that's going to be bad for you and for their users, for your users. I just wanted to sort of look at pick out, an example. Looking at why, this orange bit at the bottom with some of the newer projects happens. And there was an example. At the end of 2014, there was a quite severe networking vulnerability in Open Daylight. And, the Open Daylight team, it took them nearly 6 months, to figure out how to fix this. They didn't have a process, they didn't think about all this, up front, and then they actually realized that this was an issue for them. And once they fixed it, they basically made a bit of PR about it. So if you Google for, Open Daylight Network and PC World, you'll find the whole set of articles around it. But it really, what they then decided was to just look at how OpenStack does things, and they just copied their process at the end of the day. And I think we're seeing more examples, of that now. There are a few good off-the-shelf processes out there, like the one which OpenStack uses and Xen uses, and you can just copy them and customize them for your needs. So let's just look at this whole responsible disclosure thing in a little bit more detail, because that's the predominant model today, right? And so in the table you saw before, most of the projects today seem to fall into that bucket. So one thing I didn't really cover, we had our three phases. Basically first phase was, fixing the bug. Second phase, pre-disclosure. Third, it's publication. Now, actually, what you really want to end up with is some sort of agreed fixed period between, a bug being raised, reported to you, and you publicly announcing this. If you don't fix this, it might take months. And a lot of proprietary vendors, they often sit on vulnerabilities, for months. Something gets discovered, and it might get fixed 6 to 9 months later, or even years. But we're talking only about open source projects here, right? Typically, this should be weeks, not months, right? Then also during this yellow phase, when you're actually fixing things, there's a lot of other stuff which is going on as well. You have to look at exactly, you have to try to figure exactly out the conditions under which the vulnerability gets triggered. Are there any workarounds? Are there any config options? You have to get a CVE number allocated, and so on and so forth. Well, there's quite a bit of stuff which happens during this process. Then during this whole pre-disclosure period, that's where most of the projects really differ, quite widely. And fundamentally, what you can and can't do with the information which is shared with you, that has a big impact, on the users of your projects at different levels. And we'll look at that in a lot more detail because that's really interesting. But the key point is, small differences on how you handle aspects of this process can have, very large consequences. So there's your little butterfly, butterfly effect here. So let's just look at, an example. The disclosure time, for example. If you have a long disclosure time, for example, a few months, and you sit on that, and it comes out, afterwards, there's probably going to be a media story out there which says, well, you had a severe issue, it took you 4 months to fix it, you left people vulnerable during this time. So that discredits you as a project, and, actually just recently there was an article in the Register about Oracle, where some of these kind of accusations, were made, where they were sitting a long time on some of these vulnerabilities. There were other recent, examples as well, where it took Apple more than 6 months, to fix a cross-app resource vulnerability and a bias issue, which fundamentally left all their users, at risk for a very long time. And besides discrediting, the individual vendors or projects behind it, it also discredits the disclosure process, itself. So a lot of people don't like responsible disclosure because it's often associated with long times between a bug being identified and it being fixed. And in fact, open source projects seem to be very good in this area. We tend to do this in weeks rather than months. The other interesting thing about this is also long disclosure times also create a disincentive for reporters to report the bug to your project. Let's look at security research firms, for example. They make their money from finding bugs, reporting them, and then getting some exposure in PR after they, report it. And they don't want to have to wait for months until, or they will publish a study or a paper, and they want to be, they want to be able to do this according to their own schedule, and not have to wait, for you. They might do this once, but the next time, they might just publish the paper without, disclosing the issue to you. Then another really interesting thing is that if as a project if you say we're going to publish this thing within 3 weeks, whatever, you're setting expectations, and that helps you manage vendors in your ecosystem who might be using you and who might be putting pressure on you. And I have some really interesting stories about this later, so I'm not going to drag on about it. And I already covered that most projects typically handle this whole process within 2 or 3 weeks. So from the time somebody reports an issue to you publishing the issue, you can do this in 2 or 3 weeks. So another little element of how projects kind of differ is also, do you get a CVE number assigned or not, to an issue you find? And that's really best practice, particularly in established projects today. who are active in the Linux and cloud ecosystem. However, this kind of can have some unintended consequences, and not everybody assigns CVE numbers, in the same way. So let's just look at this, right? So actually, in CVE databases, CVE numbers are just a unique number to look at a vulnerability, and then you can find out information about it. And there's some really cool websites, such as CVE Details, to get some statistics about it, and ratings and so on. And what happens in practice is that decision makers, like people in big companies who might look at your technology, they can often use that kind of information to evaluate whether your project is secure or not, right? Now, I'm going to make the case that actually you shouldn't do that because it's sort of bollocks, but let me get to that a little bit later. So here you see some of the stats, around vulnerabilities which had CVE numbers, which show the history of, Xen. And what you see here is that in the first few years, there were very few vulnerabilities, right? Now you could think that Xen was a lot more secure around that time, but actually if you look at this, is we didn't have, all this really meant was that during this time we didn't have a process which required creating CVE numbers, right? But those kind of assumptions which go into those stats, they're not tracked anywhere, right? So if you then start comparing, projects based on those kind of informations, you might get it totally wrong. Also, if you, for example, look at some of the media coverage Xen got all of last year, there were so many media stories about one vulnerability after the other, but actually in reality, probably, in absolute numbers, last year was quite a good year compared to the 3 years beforehand. So a lot of this kind of stuff has to be taken with a pinch of salt. And you have to have a lot of background, information to make really informed decisions if you actually want to, use CVE number information to make decisions about, to find out how secure a project really is, how to deal with things, and so on and so forth. So there's other factors as well. You can't really use CVE databases to compare technologies fairly for other reasons as well, right? So first of all, you don't know when those numbers are assigned, so we covered this already. Some projects hardly ever do this, or they only do this for the most secure ones, for the most severe ones. Some projects don't assign CVE numbers at all, but then if you don't find any, and then you can assume, oh, that project has no numbers, so they have no bugs, so it must be more secure. Well, you might be totally wrong, right? Some technologies can't easily be mapped, for example, KVM on containers. They're not, they're sort of well-known and branded technologies, but if we look at it at a component perspective, what is really KVM and what is LXC, right? Most of the vulnerabilities which affect Linux and are classified as Linux vulnerabilities don't show up in KVM or LXC stats. And sometimes CVE numbers can affect several products. So this all has to be taken with a pinch of salt. So now I wanted to look at where are the key differences, and then I'll start telling a few interesting stories. So we covered a little bit about the overall length of the process. We covered a little bit around CVE numbers. But what I wanted to focus now is what happens during that pre-disclosure period, and what can happen, and where are the key differences there. And what's key here is that actually what you can and can't do if you're a privileged user who gets information to security-related information before anybody else really depends on what the goals of the process are. So I wanted to look at some of the common goals which are around there. So, the first goal, and that's a very sensible one, is that you have a fix available before it becomes publicly, before the information is out there. Another common goal is that downstream projects, projects or products, which take your open source product and repackage it in some way or form. If you look at the Linux kernel, then all your distros kind of do that, such that they can test, take that patch, package it up through the packaging manager or distribution system and test it in the environment, right? But more recently, we've also seen a lot of other goals, and that's where the whole cloud angle, comes in. So, one goal, for example, is, let's say we're talking about, a service provider who operates at really big scale, such as Amazon or Rackspace or some of the others. Well, actually, a lot of them, they need to make sure that when they upgrade the entire fleet or something, that they have staff in place. They have to put plans in place. Then they have to do some certification and testing, and that can take a week or two, right? So actually, for them, so if you then follow, a process by which you treat them like any other user, then they might be vulnerable, or their users might be vulnerable for a week or two until they kind of planned the whole thing, rolled it out and deployed it. That can be a very big issue for their users and for their businesses. And the extreme really is that you don't just allow those vendors to start planning an upgrade, you actually allow them to deploy an upgrade during the embargo period. And really what that means is, they get the information about the fix, they start planning, they deploy it, and by the time, the information about the issue becomes public, their cloud or their service is upgraded and all their users are safe, right? So these are some of those goals. And then, those goals really determine what can be done with the information which is shared with you, and, who can be on that list, who's privileged and can be on that pre-disclosure list. I wanted to classify this a little bit, into two buckets now. So we had those 4 goals. The first 2, I call that the distro model. That whole model was targeted towards Linux distros who take, open source code and they package it up and they test it, right? It's typically a very small list of vendors. They get this stuff and then they treat all of their users the same. And as soon as you start doing things special for service providers, I call that the cloud model. Obviously, a distro model that was pre-cloud computing, and as I mentioned earlier, it does leave service providers vulnerable. So, for example, if I looked at a KVM-based cloud today, as a KVM-based service provider, I don't get notified of a security vulnerability before anyone else, right? So, when that vulnerability is published, then I have to upgrade my system, and at some point I'm done, and during that time period, my users might be vulnerable to that, to that specific security issue. The same might be true. The same is not true for other technologies. Then that cloud model, that actually really only emerged recently in the last 2 years. And that is something which recognizes the needs of service providers, but it's creating some specific interesting challenges. So looking again, at this model, mapping them to technologies, right? So the distro model, Linux kernel follows it if it's reported via a distro list. All Linux distros do that, and most other open source projects which are relevant in the cloud follow this model today, where the sole purpose of the whole process is to fix the bug, package it up, and test it in the environment of those projects and their vendors who use it. The cloud model, that's kind of actually only used by very few projects today. So OpenStack does that for intermediate to high impact issues. OPNFV and Open Daylight do the same. Those projects have a close relationship to OpenStack. They basically just copied what OpenStack did. Xen Project does the same, and actually Docker also does that too. So I mentioned some trade-offs between those, between those two models. Well, the first one is actually, and I covered this sort of not so directly beforehand, it's risk for users, right? So why do you want to treat cloud service providers differently to somebody who just uses your software in a smaller environment? Well, the main reason is that they have a lot of users themselves, so a lot more people are basically being put at risk if that vulnerability comes out. And that sort of, or gets exploited. And that kind of leads almost straight into the next point, right? So it's also risk to your project's reputation. Now, I've been working with the Xen security team for a long time, and actually, we got a lot of flack. But even so, when there were security issues over the last year and a half, through a lot of very negative press stories. But actually, what was really interesting about all these stories, right, is that at no point, any users were really put at risk. Any real cloud users were really put at risk, right? So, there were all these stories. I don't know whether you remember, like at the end of 2014, Amazon had to reboot a portion of their cloud. Then the same thing happened again at the beginning of last year. And it was this huge, huge news story. But actually it was a story about Amazon's users and, other service providers' users being inconvenienced rather than being put at risk. Now, just imagine and that damaged our reputation at the end of the day. Just imagine what the damage would have been if users would have been really put at risk. That would have been a whole order of magnitude bigger, right? Another trade-off is about risk of information leakage, right? So we were talking about this process earlier, where a number of privileged companies, organizations, open source projects get access to information about vulnerabilities before everyone else. Now that's called, and a privileged list of people, we call that pre-disclosure membership. And the more people you have on that list, or organizations on that list, the bigger there is a risk of somebody, leaking this information and it going out, right? And the traditional, if you look at some of those numbers, distro model, typically the number of organizations on that list are about less than 10 people, or less than 10 organizations. If you have to include, service providers, it's a whole order of magnitude bigger, right? So the whole, so potentially, the likelihood of somebody leaking some information and something bad happening, goes up. And the main argument today against the cloud model is around, this whole risk of information leaking. Now, interestingly enough, we've been following for nearly 2.5 years this model within the Xen project, and we have about 75 organizations on a pre-disclosure list. Nobody has ever leaked anything. There have been a few hiccups where, where there were coordination issues and somebody might have disclosed some information 2 or 3 hours before the agreed time, because, they got the time zone conversion wrong, but that, that's kind of manageable. So in my view, that's not actually really an issue. And then, of course, if somebody leaks something, well, then you just fall back and follow, follow the full disclosure model, and you just publish it straight away, right? And then you have sanctions as a project as well. So if somebody leaks some information, you strip them, you take them off the list. They will never get that information again. It will be damaging, like, let's just say, a big vendor such as, okay, let's just say Amazon, right? If they leaked information, which I don't think they will ever do, we will take them off the list. That would be very bad for them in the long run. Another interesting aspect is around fairness. And let me just, and that's kind of challenging, right? So, who do you allow to be on this pre-disclosure list? When we did this originally for the Xen project, we kind of started out with what everybody else did, Distro model, and then we had Amazon, on it as well. But that created all these questions. Well, actually, if Amazon is on it, why shouldn't other service providers be on it, right? Why should one vendor be treated differently to the others? So, eventually, this created some challenges within the community, and we had a very big, discussion about this. And I'll cover that whole element in the war story section, which is coming now. Now, the fairness problem is actually a really hard one, to solve, because at the end of the day, what we have to do now is, actually, if you're a vendor or an open source project who's on a pre-disclosure list, you have an advantage to a bog standard, individual user, right? But at some point, you have to draw a line. And the only way how you then really can reconcile that is have an informed discussion within your community and come up, with something which works for you. So there's war stories. So this section is really about how did Xen come to the project, to the process we have now, and it kind of gives you a few insights of how the process also works. So we didn't have any process at all, really, until 2011, and basically we just took what Debian had and replaced Debian with Xen, pretty much. There were a few, we were having a goal of allowing us to fix issues in private and then allow distros, to package it up. We did at the time allow service providers to prepare an upgrade. So we would notify them that an issue was coming, they could test it in the environment, but they weren't allowed to deploy it during an embargo period. And basically, people who could be on that pre-disclosure list, there were Linux distros, open source or commercial, and a couple of very large service providers. One thing which was very interesting is we had no fixed disclosure time. We didn't say, we're going to fix an issue within 3 weeks or something. This was undefined. Now, that caused us some really interesting problems. So this whole section about war stories, the way how this is going to work is we have we have a starting point and we have a crisis, and how did we respond to it? So the first crisis was in July 2012, and there was this thing called the Intel threat vulnerability. And it affected, Xen, Microsoft, NetBSD, FreeBSD, and, quite a few other projects. Now, what happened at the time is, that bug was reported to us, we prepared a fix, we wanted to publish it. 2 days before we were going to publish the information, about the vulnerability, a very large pre-disclosure list member, I can't tell you any names, otherwise I might get fired, their CEO fundamentally rang every other CEO in the community and tried to put pressure on them to stop that information from being released. And because so many different organizations got involved in this, that caused a lot of friction and resentment, within the community. We, at the end of the day, stood our ground. We said we're going to release this on this day. But what then happened is, fundamentally, the CEO of that very large organization managed to talk to the person who found the bug, and they then told us, I think they may have paid them some money or something. Anyway, the date was being pushed back because the discoverer of the issue suddenly said, oh no, we now want to have this published a month later, such that everybody else has more time, to fix the issue. So that caused a lot of problems, in the community. And the key issue we had is we didn't have that fixed period. So what we did is we started a consultation about how we deal with security in the community. This process was very painful, and it took nearly a year. And it centered on a number of different topics. Like one was the easy one, timing. So, we basically now have a fixed schedule where we try to fix an issue within a week, and we have 2 weeks pre-disclosure period, and if we don't manage to deal with the issue, it gets published anyway. And in fact, we only had one instance where we didn't manage to keep to the timetable, and I'll get into that example a little bit later. It also focused on a lot of these other topics, like who should be allowed on the pre-disclosure list. If we allow X, Y, Z on that list, how would that impact other people? So there was a lot of discussion around fairness. And that was kind of really interesting because a lot of very small service providers, they felt that a security issue could put them out of business. And they felt that somebody very big, like Rackspace. So actually what we did then is, we looked at this whole thing again, we clarified the process to make it a lot more waterproof, but then we also said, well, actually, why do we have this restriction? Why do we not also allow service providers to upgrade during the embargo period? And the only reason why you wouldn't want to do that is if somebody could reverse engineer, from a deployed system what the actual vulnerability is. But in the majority of cases, if you run a service, you can't actually poke around in the actual code. You can't see the diffs between binaries, so you usually can't, reverse engineer what the issue is. So why do we have this restriction in place in the first place? So what we did, we cared that and, relaxed that whole process. And we also, there were other things, we made the application process clearer. We make the whole application process happens in public, so there's a public list. You apply for membership, other companies or people might comment on it, and everything happens in public. Also, per vulnerability, we state, can you deploy during an embargo, or can't you? What exactly are you allowed to do in this situation? And another really important thing is we put a mechanism in place, that was a private mailing list for members of that pre-disclosure list to collaborate. And that has actually helped us quite a lot, because that means, like sometimes, somebody takes a patch and then tests it on a very old version of Xen and shares it with everybody else. So that means less work, for the security team. So anyway, that's been, that's kind of pretty much where we are now. Then Venom came along, and Venom was the first time. Well, it was the first time we were affected by branded bug, but also it was the first time that we couldn't keep to our 3 weeks, right? There wasn't, we basically didn't have a week to fix the issue and 2 weeks for vendors to prepare for it. And the reason was that this was a QEMU bug. Right, so what happened is, the discoverer of the bug, they raised the QEMU bug through us. They didn't want to have to deal with the QEMU security team at the time, and we then had to wait for the QEMU security team to fix the issue, and so we ran out of time. And what that then led to is that, vendors only had like 3 days, to prepare and deploy the patch. And anyway, to cut the long story short, we have a retrospection process, and what we're now doing is, if we don't, if there's a chance, if we don't manage to provide a fix in a week, we warn everybody anyway that there's an issue, but that we don't have a fix, and please help us, right? So at least they can prepare and they know what's coming. So, what lessons, have we learned from that? Well, actually, that larger pre-disclosure list hasn't really caused an issue for the project. There have been no leaks. We haven't had a single 0-day vulnerability. Obviously there might be some which we don't know about, but that applies to everyone. The other really interesting thing is that a well-run process builds trust. So, we've learned so much about the vendors in the ecosystem by working through them, and so we have now this capability to, to collaboratively improve things as we go forward. And fairness, is a difficult issue, and then there's always some practical issues which you can never, get around, such as people will interpret policies in different ways, and you don't always get it right. And I'll just skip this quickly. Now, one really interesting thing is security and media hype. Because if you do things in a very transparent way, what will happen, you're giving the media a chance to talk about this, and that isn't always very nice. And that is something, really, if you are running a security vulnerability process for an open source project, you have to be very aware of this. So every single time now there's a security vulnerability related to Xen, there's probably going to be a news story about it. These are just some examples. Every single time we have a vulnerability, there's 2 or 3 articles about it, and it doesn't matter how whether it's critical or not critical, there's always going to be a story. So why is this the case? Well, first of all, security stories are hot. They're clickbaits. People just click on them. And because Xen is widely used, and there's this indirect link, to Amazon and other big users, it makes it even more interesting. And what I suspect, for example, like Docker, I mentioned earlier that they don't publish their security policy. I have they're also a hot project. I have a feeling that, they're worried about that kind of, that some of the information there might be exploited. It's too easy for reporters to write a news story. So, like whenever we work on a security vulnerability, there's a website which tells you that something is coming. So that means, and it tells you when we're publishing it. So that means that reporters, they go to this website and then they know exactly, when they need to look again to write the story. Now, what's interesting is, now in the community we have these values around transparency, and everything has to be transparent, so we can't get away from this. Other projects like OpenStack are slightly less transparent, about this, right? They largely follow the same process, but they don't advertise that, on a certain date, security issue is coming, so they get picked on less by the press. So coming back to the original, question, are the security practices robust enough for cloud computing? Well, I think there's a very wide range of approaches, and really, software stacks are getting more and more complex. There's lots of layers, and there is the weakest link, in your software stack from a process perspective. There are some good best practices around, like what we and OpenStack do, and more open source organizations are copying that model now, so I would encourage you, to also do that going forward. What's slightly worrying is that new projects don't think about security management straight from the beginning. You should really think about this from very early on. And there's the whole thing about post-Snowden, media pressure, and that will never go away. We were hoping last year that, the Register and other press outlets would get bored with SEN-related security stories, but that's just not going to happen. They will just keep on writing about it. And what this is doing is it's actually forcing us as a project to address some issues. Like, an example is, like cloud reboots were very big stories. So what we're now doing is, as a community, we're implementing functionality which avoids cloud reboots, such that you can just take a security fix and deploy it on a running system, and then that whole segment of issues goes away. We have a similar thing around, we had a lot of issues which were caused by us by QEMU. So we're sandboxing QEMU, within a platform. So, what this whole media scrutiny is forcing us with is to tackle some of those common roots, where we get media coverage, and just remove those angles such that the reputation of the project doesn't get damaged in the long run. And that's really it. If you have questions, just go ahead.
So the slide where you said that cloud is made things different, and you said that maybe there's more visibility, but less actual impact on users, right? It was the slide, I think, before fairness, right?
So I think this comes down to how many, it comes down to how many users are impacted at the end of the day. Now, like traditionally as an open source project, you often think about your direct users, right? And you might have a relationship to them. But what service providers now do, you have one user, maybe one corporate user who runs a very large, service, and they then also have users, and that number of users might actually, outnumber the number of the direct users you have, right? So at the end of the day, you then have to make the decision, what creates the most damage to the most people, for you as a project? And that's kind of, if you look at XEN, we have AWS, Alibaba, Tencent, all those big cloud providers. If you take all their users together, that's a whole order of magnitude bigger than, individual users, which are around.
So I guess maybe I misinterpreted that slide. So you're saying with cloud, you actually have more.
You have more, yes, exactly. You have more impact. Yeah. So there's, so by one of those vendors not being able to update the system in a timely manner, you might suddenly impact, millions of users and magnify, the problem a lot more. Yeah.
I expect that the service providers like Amazon, they have very customized versions of Zen.
Well, some of them do, but some of them don't, right? So, and of course, even if you have something customized, you still use probably a common code base, right?
But have you encountered a situation when your fix is not actually fixed to there? the software they use.
Well, but they wouldn't necessarily tell us that, right? So, and why would they, right? So it's conceivable, but, I don't know whether, there was actually a series of articles from Amazon that what they're doing is they intentionally they run very different configurations to de-risk their installation sometimes, right? So what they, I don't know what that means in practice. They might have 10 slightly different versions of Xen running the same thing, such to de-risk their, that's what it sounds like, but I don't work for them, I don't know.
That's the answer.
Any more questions? Cool. Okay, thank you very much. I hope you enjoyed the talk. And thanks for sticking around for so long.